Day one, we are starting talking about similarity. And we're basically going to be talking about similarity in triangles. Similarity in triangles. Hang on, y'all. All right, so let's just fill in the blanks. Similar polygons. Y'all know what a polygon is, right? It's just a shape. Triangles are the most basic ones, right? But this also works for quadrilaterals, pentagons, hexagons, heptagons, all those gons, okay? So similar polygons have the same shape, but they have a different size. They look like the same shape. They're both triangles would be similar with triangles and rectangles with rectangles and whatever. They have the same shape, but they're a different size. So remember, referring back to transformations that we did in Unit 2, a similar congruent figures were when we did a reflection, rotation, or translation, right? We produced a congruent figure. They were exactly the same shape, exactly the same size. But when we did a dilation, we either enlarged it or shrunk it, right? So that produced a similar figure, not a congruent figure. So polygons are similar if corresponding angles are congruent. Congruent symbol looks stupid. Corresponding angles are congruent, and corresponding sides are not going to be congruent. Corresponding sides are going to be proportional. So congruent figures, remember, had congruent angles and congruent side measures. Similar figures are going to have congruent angles but proportional sides. Okay, so the only difference is the lengths of the sides are not going to be the same, but they're going to be proportional. Okay, the angles are all still going to be congruent. Okay, the ratio of corresponding sides is called the scale factor. Scale factor. Now, didn't that sound like dilations? Didn't we have a scale factor in dilations? Okay, so that's another correlation there, that dilations and similar figures are produced by a dilation. They involve a scale factor. Okay, if polygons are similar, then their perimeters are also similar, or proportional, I should say. Perimeter. I cannot spell. Now, what's a perimeter? Yeah, the distance around a figure. So the sides are going to be proportional, and the perimeters will also be proportional. Okay, according to the scale factor. So we're going to do a little practice with scale factors right here. So these two figures we're going to use these two figures here to fill in these three boxes. Okay, now notice what it says over here to the side. In a scale factor, order matters. So when we name a similarity statement, the order of the letters corresponds to what angles they match up with, which angles they're congruent, just like a congruency statement does. All right? And also, it tells you which sides are proportional to each other. Okay? So, it says, what is the scale factor of triangle ABC, which is a smaller triangle, to triangle DEF? So what you do is you find two sides that are proportional to each other. Okay? So segment AB right here is proportional to what? DE. So that's going to be 8 over 12. And a proportion is another word for a fraction, right? So we set up the fraction 8 over 12. And then you reduce it. What is 8 over 12 as a fraction reduced to? 3 both divisible by 4? 2/3. So the scale factor from triangle ABC to triangle DEF is 2/3. That means this triangle is 2/3 the size of this one, right? The scale factor is smaller than 1, so that means this triangle is smaller than this one, right? Okay, this one says, what's the scale factor of triangle DEF to ABC? That means you find a pair of corresponding sides on DEF and relate it to one on triangle ABC. So let's just do that one. Let's do number 21, DF. So DF is 21. What does it correspond with in the smaller triangle? AC, which is what? 14. And those are both divisible by 7, aren't they? Which is what? 3/2? Do you see how these are reciprocals of each other? When I go from the small one to the big one, it's the reciprocal of going from the bigger one to the smaller one. Okay, so to get the scale factor, you're going to find a pair of corresponding sides, write that as a ratio, and then reduce to fraction. Does that make sense? And if smaller to bigger, it's going to be smaller than 1. Bigger to smaller, it's going to be larger than 1. So that would be a enlargement, and that would be a shrinkage. All right, what's the ratio of the perimeter of triangle DEF to ABC? So whatever it mentions first, that's in the numerator. That goes on top, right? How will we get the perimeter of DEF? Add all the sides. I don't know, my calculator's in my backpack because I was supposed to grade papers this weekend and I didn't. 12 plus 15 plus 21. What is that? 48 over 8 plus 10 plus 14 is how much? 32. And you can simplify that. If you want to, you can do math enter to simplify, can't you? Right? Y'all know how to do that with a calculator? 48 divided by 32, math enter. Or they're both divisible by 16. What is it? 3/2. Do you see anything similar? So the perimeter from DEF to ABC is the same as the measures of the sides from DEF to ABC. Do y'all see that? So didn't we say up there that perimeters are also going to be proportional? So sides will have the same scale factor and perimeters will have the same scale factor. Does that make sense? So this fraction we reduce to is the scale factor. Does that make sense? Okay. So similarity statements. The symbol for similarity is just a squiggle. Squiggle. So if you want to write that on that symbol sheet we got at the very beginning of the semester, you can later. But the symbol for similarity is the squiggle. So for congruent, you know it's a squiggle on top of an equal sign, right? For similarity, it's just a squiggle. So if you just have a similarity statement, you're supposed to say triangle ABC is squiggle triangle DEF or whatever. Okay? So you need to know the difference in seeing this symbol compared to a congruent symbol. Now it says, write a similarity statement for the triangles above. Let me scroll it so I can see both triangles. All right, so you're going to have triangle blah, blah, blah is similar to triangle blah, blah, blah. Make sure you match up congruent angles. Okay? Now, aren't the angles marked congruent? I'll see that with 1 arc, 2 arcs, or 3 arcs. So, angle A is congruent to what angle in the second triangle? D. Angle B is congruent to E. And angle C is congruent to F. So, the angles are still congruent even though sides are proportional. Okay? So that is a similarity statement. You have a squiggle between the two triangles. And I say triangles, we're mostly going to be dealing with triangles in this unit, but today we might see a few like quadrilaterals or something. Okay? All right. Okay. This number 1 right here says list all congruent angles and write a proportion that relates the corresponding sides. Do you see how they did a similarity statement at the very front? Y'all see that similarity statement? That is key. That is more important than the picture. Okay, that is going to be more helpful than a picture anytime you see a similarity statement. So angle J is congruent to what angle? P. Very good. Angle K is congruent to what angle? M. And angle L is congruent to what angle? N. Okay? Corresponding parts are in the same position. Okay? So, also from the similarity statement, JK is proportional to what segment in the second triangle? PM. And they're proportional, so I'm going to write equal signs throughout. Okay? I'm going to have 3 fractions equal to each other. KL is proportional to what side? MN. Why do I have 2 M's there? It's supposed to be PM on the bottom, isn't it? Sorry, y'all. MN. And JL is proportional to what side? PN. And excuse my sloppiness, y'all. Y'all see that? Whoa. So to me, the pictures are not nearly as helpful as the little similarity statement. Does that make sense? So that will help you in setting up ratios for side lengths, and it'll also help you finding angle measures because you know which ones are congruent to which ones. All right. We're going to skip to number 4 and actually start doing some proportions just to save time. Because I figure y'all can do that with all of them, right? Because they're all similarity statements, so you can easily do that. I've showed y'all how to do that before, haven't I? Okay. So on number 4, we're going to start finding the lengths of sides. Okay? It says, if the figures below are similar with a scale factor of 2 to 3, find the value of x. Well, the scale factor is 2 to 3. So that means from this quadrilateral to this quadrilateral, the scale factor is 2/3, right? So instead of writing it with the colon, write it as a fraction. The first one is your numerator always. And your second one is your denominator. So we know that the sides are proportional. So this sides right here, these are corresponding sides because you see how the quadrilaterals are in the same position, right? If they're in the exact same position, then it's going to be match up with what it's in the same spot. Does that make sense? Probably not, but that's what it is. So you're going to set 2/3 equal to 42 over x. That's how you're going to set up your proportion. You're going to use your scale factor. It's always easiest if they tell you a scale factor. They're not always going to do that. All right? Use your scale factor and set it equal to your corresponding sides. How do we solve a proportion? Cross multiply. Very good. So 2 times x is 2x equals, what's 3 times 42? 126. And then how do I solve for x? Divide by 2 everywhere. And x equals 63. Yeah, calculators are our friends. And it did not tell us units, inches, or anything, so we're just going to leave it 63. And you can check it. How can I check this? Yeah, I can say this is 63 and do 42 over 63 and see if it reduces to 2/3. Right? And you can math enter that and it should work. Right? Okay. Good thing to do to check these. All right, number 5. The figures below are similar with a scale factor of 6 to 5. I'm going to change that to 6 over 5. Find the value of x. Now, are these two proportional sides? Wait, yeah. Yeah, because you think about it, you would flip and rotate this triangle and it would be in the same spot. Y'all see that? They're proportional. Okay. So sometimes we have to do a little page flipping to figure it out. And it's going to be big over little. Y'all see that? because it's an improper fraction. So it's going to be the big length over those little triangles' length. All right? So 6 over 5. What's the length of the big triangle? X over what's the length of the smaller one? 28. Okay with that? Cross multiply with me. 5 times x is 5x. What's 6 times 28? 168. And we're going to have a decimal. That's okay. I don't know why I'm dividing by 8. Divide by 5 on both sides. And x is approximately, or is it exactly? It's exactly 33.6, right? So you just set it up and solve the proportion. Use your scale factor. Any questions on those two? Okay. Look at number 6, a little bit different setup. This time they did not tell me a scale factor, did they? No. But they gave me a similarity statement. To me, that's even better. Okay? They told me which side is proportional to which side. Do we have a pair of sides where we know both of the measures? A pair of corresponding sides that we know both the measures? Yeah, what? BC goes with EF. Do I know both BC and EF? Yes. So I'm going to do big over little because this is the bigger triangle, right? So I'm going to say 28 over 20. And plus, I like to go left to right anyway. It's less confusing. 28 over 20 equals, does AB correspond to DE up here? Yes. So you want to double check that. So AB is what? X over DE is 25. So use your similarity statement to make sure you know what corresponds with which side to set up your proportion. Is that okay with everybody? Then we cross multiply. What's 20 times x? 20x equals, what's 28 times 25? 700. Nice. Divide by 20. X equals what? 35. Okay. Any questions about that? Okay, on number 7, they gave us 2 quadrilaterals, and we have a similarity statement. Okay, and we're looking for x. Now, we're looking for this little side x. We're not looking for angle x. Y'all see the difference? Okay, they use lower cases for segments and capitals for angles. Now, what's a pair of corresponding sides where we know both of them? Yeah, because if you look, PS is the only side I know over here, and PS is first and last, corresponds with first and last over here, which is WZ, which is 40. Y'all see that? So I'm going to say 75 over 40 equals, X is in the big quadrilateral, over what does it correspond with? And I'm going to double check. Does RS correspond with ZY? Yes. Okay? Because sometimes they might tell you all of the side measures. And so you have to make sure you set up corresponding with corresponding. Does that make sense? Okay. So make sure you always double check with your similarity statement. Cross multiply. 40 times X is 40X. What's 75 times 32? 2,400 divided by 40. I'm going to cancel a 0. X is what? 60. And again, they did not tell me any units. Any questions so far? All right, they're going to start getting slightly more complicated right about now. So number 8, I told you they're going to start giving you more information, right? And also notice on number 8, you have an X and a Y to find, don't you? So what do y'all want to start with, X or Y? Y'all want to start with X. Okay, so if we're starting with X, I need to find the pair of corresponding sides that I know both of them. So obviously it's going to be HJ and something. What does HJ go with? DE. So I'm going to start with DE over HJ. DE is 9. Y'all with me? And HJ is 15. So those are the two I know. Now, if you want to, you can reduce that. I'm just going to leave it 9/15 because that's what I know. And X is GH, and it's in the second triangle, so it's going to go on bottom. And what does GH correspond with? DF. So what's going to go on top of X? 12. Now look at my proportions for a second because I want to make sure y'all understand that. Both of these, this and this are both in the left triangle. Y'all see that? And this are both in the right triangle. The one to the right, not a right triangle. Y'all see that? So make sure you have proportional things on the same row. Does that make sense? Okay. Cross multiply that. 9x equals, what's 15 times 12? 180. Divide by 9. And x equals 20. Okay. There's x. Now let's do y. So I'm going to still start with that 9/15 because I knew both of those to start with, right? So y is in the second triangle and so is 15. So I'm going to put y on the bottom. Now what is the length in this triangle that goes with y? It was GJ, which is EF, which is 14. Y'all see that? Okay. Cross multiply. 9 times y is 9y. 15 times 14 is 210. Divide by 9. Y equals what? Yeah, I'm going to say 23 1/3. If you put the 0.3, make sure you put the bar over it, or it's technically not correct. Y'all see how we did that? So make sure you start with a pair of corresponding sides that you know both of their measures. Okay? If you want to, instead of 9/15, you can reduce that to 3/5. Right? The scale factor is 3 to 5. Okay, and that would give you smaller numbers so you're not multiplying and getting big O numbers. Okay. Look at number 9. They kind of have those pictures drawn together. This makes it a little bit more complicated sometimes. But again, they gave us the similarity statement. So when they give you the similarity statement, that makes it a little bit easier. Okay, we want to find a pair of corresponding sides that we know both of the measures to. What are they? JK and MN. Do I know both of those? Yes. So JK is 40/16. And those are both divisible by 8, right? I'm going to go ahead and reduce that so I don't have such big numbers this time. So what is that, 5/2? So that's the scale factor. Okay. So I'm going to use 5/2 instead of 40/16, if that's okay. So 5/2. So I have my left triangle on top and the right one on the bottom. Y'all see that? Okay, so let's do X. KL is in the left triangle, and it goes with the 5 then. What side in the little triangle corresponds with X? KL goes with ML, which is 14. So there's my proportion to find X. Is everybody okay with that? Okay, cross multiply. 2 times X is 2X. 5 times 14 is what? 70. Divide by 2. X equals 35. Good. All right. To find my Y, I'm going to use 5/2 again. Again, you could use 40/16 if you want to, but we simplified that so we could use smaller numbers. So Y is LN. And LN corresponds to what? JL, which is 45. So that's going to be 45/Y. So do you see how I have my left triangles both on top and my right side triangles both on the bottom? Okay, that's important. So cross multiply. 5 times y is 5y equals, what's 2 times 45? 90. Divided by 5, and y equals what? 18. Now you can check these, okay? You can check and see if 45 over 18 reduces to 5 over 2. They do. They're both divisible by 9, right? And you can check to see if 35 over 14 both reduce down to 5 over 2. And they do if you divide by 7, right? Right? So that's a pretty smart thing for you to do is check your proportions with your scale factor when you're finished. They all should reduce down to the same scale factor. All right, number 10 started putting some algebra on us. More than just proportions. But again, number 10, at least they gave me the similarity statement. That was nice of them. Anytime they give me that statement, I'm grateful because it helps me see what goes with what. So let me just make a proportion. 32, and these both have x's, so I really can't get down to one scale factor. So I'm just going to start with making fractions. 32, which is GA, goes with which one? KX, which is x plus 3, right? So 32 over x plus 3 is one fraction. Over, or equals, 36 goes with, make sure GM goes with XD. Yes, they do. So 36 over x plus 6. Is everybody okay with how we set that up? All right, how do you cross multiply when you have pluses and minuses? Now remember, I taught you this now. You gotta set up distributive property. Okay? You gotta set up distributive property if you have pluses and minuses with your x's. So on one side, it's going to be 32 times x plus 6. And on the other side, it's going to be 36 times x plus 3. So if you have pluses and minuses, you got to set up distributive property. And then you distribute. 32 times x is 32x. And 32 times 6 is, I believe you, 192. Equals 36 times x is 36x. Plus, what's 36 times 3? 108? Okay so far? Then it's an equation. I get my variables together, so I'm going to subtract 32x on both sides. So I'm getting 192 equals 4x plus 108. Then I subtract 108 on both sides. What's 192 minus 108? How much? 80. Huh? It's 84? Okay. My notes, I was dyslexic. Divide by 4. And x is what? 21. So on that one, the only difference is when you have pluses and minuses, you got to distribute when you cross multiply. All right. How about let's do number 11 as a you try. Whoa, it says, sorry. It says find LY. So that means after you get X, that's all I had to do on number 10. So after you get X, you plug it in and find the length of LY. Does that make sense? All right, y'all try it. Set up your proportion, solve it for X, and then go back and plug in and get LY. Use your similarity statement. We can't do anything with radical 3. It's not going to divide out. If I have -4 over 2, what does that reduce to? Now, I don't care if you use it exactly like the numbers say, or if you reduce it down and get your skill factor. However it makes sense to you. Still should get the same thing for X as everybody else.
We don't have to write the one in front of the radical because the way it's written is understood to be one. Because everyone understands how that symbol. Right? You can't do it unless underneath the radical, because remember what's underneath the radical can't be checked. Unless you got to write this over radical 3. That is one. Yeah. Right? So our two solutions here are -2 plus radical 3 and -2 minus radical 3. Okay, then I'll calculate. Okay, so the first approximate solution we have -2 plus second x squared 3. So if we're going to the thousandth place, 9 tells 7 to do what? To go up. So we're going to have -0.268. So there's our first approximate solution. Now we're going to find the next approximate solution. We're going to have -2 minus x squared 3. And that's about -3.732. We're going to tell 2 to save the spot. So there's our two solutions, exact and function.
Good.
So we okay?
That's good.
Yeah, I don't know how to do it.
That's one
One
of
of
the
the last times, they're working on it.
Okay, but that's not that one.
They're proportional, not congruent.
Oh,
Sides are not congruent, they're proportional. You missed the whole point of my lesson.
Yeah. So what that means, you have to simplify right to 12. But I can't.
With over 10 is correct. And then it should be 4x minus 1 over x plus 5. Good. And then cross multiply.
Yeah. So now we need to identify A, B, and C. We're solving with the quadratic formula.
Okay.
What about this? And what about this? You also need the formula. All right.
Hurry up and here. Keep going. Good. 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 All right. So I started just putting corresponding stuff together. 25 TL goes with what? CH. So you can use 25 over 10 for your proportion, or you can reduce that to 5 over 2. Who used 25 over 10 straight up? Who reduced it to 5 over 2? Okay. You're going to get the same thing either way. Okay? Okay? Either way. I'm just going to use 25 over 10 because it looked like most of y'all did that. If not, it don't matter. So then that LY, 4x minus 1, corresponds to HK, which is x plus 5. Y'all with me? And when we cross multiply, we have to distribute. So on one side of your equals, you have 25 times x plus 5. And on the other side, you have 10 times 4x minus 1. If you don't distribute here, you're going to miss it. Because the common mistake is people will multiply 10 times 4x, but they forget to multiply 10 times -1. So that's why I want you to set it up like distributive property so you don't skip something. All right? So if I'm multiplying by 25, on one side I have 25x plus 125 equals 40x minus 10. And I'm going to subtract my 25x to get my x's together. 125 equals what? 15x minus 10. And I add my 10. 135 equals 15x. Divide by 15. And I forget. What do I get? 9 equals x. Raise your hand if you got 9 for x. I believe everybody just about did. And then you want to find LY. Well, LY is 4x minus 1, right? So for the length of LY, you say 4 times 9 minus 1. 4 times 9 is 36, minus 1 is 35. Raise your hand if you got 35 for the length of LY. Any questions there? All right, let's look at number 12. This is going to be the last one we do today. Do you see how this is two similar triangles, but one's inside the other? Y'all see that? Now these look like right triangles, even though they don't say they are. They look like it, but they don't matter if they look like it or not. There's one inside the other. On your practice today, I think you'll have one like this. Okay? Similar to that. Okay? So it's just one inside the other, but they're similar to each other. They share that angle B. Do y'all see that? And you can see that in the similarity statement that B is congruent to B. You see that? Okay. So, it told me some things that are not drawn on the picture. It tells me that BG, which this whole thing, is 18, right? Right? And they tell me that BR, which is this whole thing, is 4x plus 7. So whatever is not drawn or labeled on the picture, make sure that you label it. Okay, so I got my little triangle and I got my big triangle. So I'm going to compare them like that, little and big. Little and big. My notes keep getting covered. So I'm going to do my little Sugarfoot. I'm going to do my little triangle stuff on the top and my big one on the bottom. Okay? So on my little triangle, the side length 12 corresponds to what side length in the big triangle? BR, which is 4x plus 7, right? And then 8 on my little triangle, which is BV, corresponds to which one in the big triangle? BG, which is 18. So I have my little stuff on top of my big stuff, my little triangle stuff on top of my big triangle stuff. Y'all see that? So sometimes it helps me if I label my little stuff's on top, my big stuff's on the right, or my left triangle stuff's on the top, my right one's on the bottom. Okay? Cross multiply from there. There's a plus sign, so I'm going to have to distribute. So 8 times, parentheses, 4x plus 7 equals, what's 12 times 18? 216. And then I distribute 32x plus 56 equals 216. Subtract 56. 32x equals what then? 160. And divide by 32. And x equals what? 5. And that's all it said was find the value of x, correct? Okay. So any questions about how we did that one inside the other? Just label your work, y'all. All right, that is the end of notes for today. We're not going to do that back page in notes. Hope you enjoyed today's lesson.